Now, we will learn basics of SQL so that you can retrieve information from databases. The basic syntax for SQL is very simple compared to human languages, and it has only a few keywords that the software understands that are easy for people to learn. Most of the keywords you need to know are on the slide. There are 5 keywords: select, from, where, group by, and order by. The grammar, called the syntax in computer programming, is very simple. SQL follows the pattern of keyword followed by the parameters that specify what you want. At the very end is a semicolon that simply tells the computer you are done with your statement, like a period in English, which means now it is time for the computer to run your statement. What is in red, that is select, from, and semicolon, is always required. The rest is optional depending on what you want to do. Let's break this down one step at a time. As we do this, try to follow along using the SQLite software that you should have installed already in the first SQL lab you completed. Download from Google Drive the CUM database and load it into SQLite. Note that you will be using the database throughout the lab, lectures, and assignments, so be careful not to edit the database by accident, because if you edit the database, your answer may not be correct. If that happens, download it again and start over. The best way to avoid this is to open database read only in SQLite. It will prevent any editing of the database. It is very important for you to look at your data as you work with it. Even if it is big, get into the habit of just looking at a subset to get a feel for your data. In SQLite, you can click on Browse Data and select your table. Also included on the Google Drive is an Excel file in case you prefer to look at the data that way. First, you want to think about what columns you want to get from the database and which table it's coming from. Using this information, you just have to write it up in SQL syntax that the computer can understand so it can get these things for you. You do this by using the keyword select, followed by the list of columns you want, separated by commas. After that, you type the keyword from and follow this by the name of the table. For example, you can display first and last name of all patients by typing in select fname, comma, lname from patients, semicolon. Now you try it. Try to write the SQL query to display diagnosis and visit date for all patients. What table has this information? Which columns do you need? Pause the video and try it. Then restart the video after you are done. Yes, you should have select DTL underscore DOS, standing for detailed date of service, comma, diag1, comma, diag2, comma, diag3 from visits, semicolon. So how would you tell SQLite that you want all the columns? That may be a lot of typing. To make that easier, there is a shorthand that SQLite understands that follow what we call regular expressions. For now, you just have to know that asterisk means all columns. So you type in select asterisk from patients, semicolon. Then it will return everything. Now it's time to select the rows you want. This is done by the where statement. You follow the where keyword with a conditional expression that states which rows you want. That means you need to learn to write conditional expressions. This may be the most technical part you need to learn. In this class, we will try to keep to relatively simple conditionals. So in our example, we want to only keep rows of patients who are Hispanic. The conditional expression, given the way the data is stored in that column, would be race equal to large H in quotes. It must be exactly this way with quotes and large H. Remember, Computers need precision and only know how to do certain things a certain way. So you have to adjust to the computer and not the other way around. If you want to have the computer effectively assist you so you can do what you want, you have to be the adult and learn to speak to your computer. The full SQL query would be as seen here. Now your turn. How would you find patients who are adults when adults are defined as 18 or older? Again, pause the video and restart when you're ready. Yes, the conditional statement is written as where age is greater than or equal to 18. Here are a few more conditionals to consider. Do you see how this works? The next video will cover how to build conditional expressions and Boolean expressions in more detail. It will be important to spend some time to learn it. Once you have the data extracted to the columns and rows you wanted, you can now sort it using the order by statement. You can sort output by contents of a column. You can sort in ascending or descending order. And you can also sort by more than one column, where the second one breaks ties. Here's an example of sorting by patient's last name in descending order. If nothing is specified, the default is ascending. Now your turn. Try sorting patients by age. Are you done? You should have select asterisk from patients, order by age. And a bonus. Here is how you can get just the top 5 youngest patients using the limit keyword. Let's recap what we have learned till now. Every SQL query will return a table of values as output. Sometimes there is only one row or even none. You can build simple SQL queries using only a small handful of keywords such as select, from, where, and order by. Now, let's learn about aggregating rows and columns. Before we can move on to the last 2 keywords, as and group by, let's talk a little about table operations. In a table, there are 2 basic operations you can do. You can aggregate columns or rows. Aggregating columns is when you want to calculate a new column using the existing columns. This is done with the keyword as, followed by the new column name, as seen above. You specify how to calculate the new column before the keyword as. Similarly, aggregating rows is when you want to roll up multiple rows into one row. This is done with the keyword group by, followed by the list of variables you would like to roll up, as done below. Rolling up rows means that you will create a new table that will group all rows with the same values in the group by variables into one row. As with columns, you also have to specify how you want to combine the multiple rows, such as sum up or take the average, max, or min. So, for example, you may want to sum the cost of all visits on the same day in the payment table. Let's look at the syntax carefully one at a time now. Here is an example for calculating the discount amount by subtracting the covered amount from the billed amount. In this example, we retain 3 columns: patient ID, billed, and covered. Then calculate the new variable discount amount. How many columns do you think this query will return? Yes, it would return 4 columns: patient ID, billed, covered, and the new column, discount. Note that when calculating new columns, it is worth putting in some effort to name it well, that is short and succinct but meaningful. Meaningful names will go a long way in better keeping track of your work. This is very important for the iterative spiral that is often needed for the fine-tuning in data analysis. Similarly, including key comments in your code is important, again to help you better keep track of your work for the iterative spiral process. All programming languages have syntax for commenting in the code. SQL-like commenting syntax is to start the line with 2 dashes. This indicates to the computer to ignore what comes after, as it is comments for people and not things the computer has to execute. So you can write in whatever comment you want following the 2 dashes and end it with a semicolon to indicate you are done commenting. The general rule of thumb is to try to document things so you can read it and remember enough to pick up something you left 6 months ago. Again, now it is your turn. Try to add a new column in the payments table for the total paid amount, defined as the sum of copay, patient paid, and insurance paid. Pause the video and take your time trying this. When you are done, start again. Did you get it right? What did you name your new variable? The group by statement can make calculations on groups of rows into one row. For example, summing, averaging, taking the max min, or counting how many rows in the group. Each different value of the group by fields defines a new group. And in the output table, there is one row that is produced per each group. Thus, when several rows of the input table belongs to the same group, they are aggregated using the aggregation operator specified on the variable. Here is the SQL query that will return a table with the total billed per patient. It is grouping up rows by patient ID, then summing up the billed column per patient ID and storing it in the total billed column. How many columns would this query return? Yes, you would get back a table with 2 columns, patient ID and total bill per patient. What if you wanted to know the total bill for a given patient? How would you write the SQL query? Yes, you add the where conditional statement where you can specify which patient you need this information for. So do you think this will work? Try it. Does it work? No, in SQLite, the order of the statements have to be correct. The where statement must come before the group by statement like this. Also note that in this case, you will either get only one row back for the one patient or no rows back if there is no information about the patient in the database. Joins allow you to combine multiple tables in your SQL query. It can combine rows from one table with the rows in another table. But more often, you are joining multiple tables to bring in more columns from another table. When joining the different tables, you must specify which rows from the first table should be linked to which rows in the second table. This is usually done in the where statement, where you can specify which common columns from the 2 tables should be used for the linkage. Here is an example. Generate a list of bills for all patients with their name. First, you should think through all the tables we need for this query. Since the patient names are in the patient table, we will need that. But the billing information is in the payments table, so we will also need that. Now, put the names of these tables in the from statement separated by commas. Second, once you have all the tables you need, you should look at the primary and foreign keys in the tables to determine which variable should be used for the linkage. In this case, we see that the patient ID exists in both tables and is best to use when linking the 2 tables. Now, put this condition in the where statement like this. Note that when you have more than one table in the where statement, you must specify the name of the table for every variable you use. Syntax-wise, you do this by writing the table name first, followed by a dot and then the variable name. We are almost done. Now that you have specified the table you need and how to join them, you can simply list out the variables you want in the select statement, making sure to specify which table the variable should be pulled from. Here is the final SQL query. Read it carefully. Do you see how it is done? Just like in English, there are many ways to say the same thing to a computer. For example, there are two ways to join two tables and select some variables from both tables. One used the keywords we learned, select, from, and where. The other one uses a new keyword, join. When you use the join keyword, you also have to use the on statement to specify how to link the tables instead of the where statement. There are 4 different ways to join tables depending on what rows are kept in the final output. As seen in the Venn diagrams on the bottom, inner join keeps only the rows in both tables. Left join keeps all rows from the left table, and right join keeps all rows from the right table. Finally, full join will keep all rows that are in either of the tables. Now that you have learned how to build SQL queries from multiple tables, let's talk about how you may do more complicated queries that require multiple steps. In this case, you will need to save your queries so that you can call the output tables on subsequent queries. The way you do this is to create virtual tables called views. Views look and feel like a real table because it is the saved query and the output from the query is the view. They are called virtual tables because although you treat them like any table in the database, it is not a real table that is stored in the DB. Rather, it is the output of a saved query. It can be treated the same as a real table. If you opened database read-only, you will not be able to save a query as a view. So close your database and you will have to reopen database normally. But before you do that, you may want to make a copy of the original CumDB and rename it, for example, as myCumDB before you load it in as Open Database. This way, you can have the original CumDB that has not changed and your new myCumDB where you can save your views. Note that if you try to create a view with the same name as before, you will get a warning because you cannot overwrite what is there. So you'll have to use a different name. It is simple to create a view by using the right keywords. Keywords create view, followed by the name of the virtual table you want to use, and the keyword as. You put this create view statement in front of your select statement. Then the output from this query can now be called by using the view name panel. In this example, we create a new view called panel that links the provider table with the patients table and keeps the first and last names of the patients and doctors. The keyword as is used to rename the column names in the provider tables so that the column names for patients and providers are different. Can you tell how many columns will be in the view called panel? Yes, you will have 4 columns, 2 for provider's first and last name and 2 for patient's first and last name. The provider's first and last name columns are called doctor first and doctor last, and the patient's first and last name columns are called F name and L name. Now, try running this example in SQLite. What do you see? No table this time? Yes. If you create a view and save the query, you will not get the table returned to you as before. Instead, you'll have to go to the Browse Data tab. Then when you look at what tables you have, you will see a new table called Panel. But the icon will look different. The icon with the green box inside indicates that it is a virtual table and not a real table. But if you load the virtual table, it will load in just like a real table, and you can treat it as a real table for all purposes. Congratulations! You should now be able to query a database and extract information from it.